So in this content, we're going to talk about writing and balancing chemical reactions. So I should also have writing up here. So we're not just balancing is going to be the main thing, but also just being able to write the balanced equation. So there's a series of steps, and I actually decided this year I would look through a couple of different books to see because I've always just taught it. You just kind of figure it out. And our Zumdahl book does it the same way that I've always taught it, but I looked through a couple of others, and there's not real consistency on this. It's essentially balancing by inspection, which just means hopefully you see it. And sometimes it's hard to see. But there's a few key things that I want to point out, and then we'll just do examples. So first thing is we already did some of writing a reaction, right? So my abbreviation for reaction is RxN. So we'll write the reaction, and it's a mathematical equation. So we'll write this reaction with reactants on the left and products on the right. And that's just, a reaction can go back and forth. It could go from right to left. But when we write it, it's like this. Reactants over here. A right arrow means is produced by, or the reaction proceeds, and then products. And of course, we could write it A going to B, or B going to A. Either way, we want to look at it. But in the stoichiometry chapters, chapters 3 and 4, we're talking about reactions that we only have the things we start with, the reactants, and the things we end with, the products. Okay, so whenever you see molecules or atoms on the left, we call those the reactants. Molecules or atoms on the right, we call those the products. And then when we write that, so we're going to indicate the physical state. And that's if known. Sometimes we'll skip this step just to make it easier, a little less cumbersome, especially on WebAssign. But most of the time we're going to include it. And so the physical state abbreviation, so it could be that it's a solid and we put an S. Could be that it's a liquid. So we put an L. Could be a gas. I guess you probably guess that's a G. Or if it's in aqueous solution, so dissolved in water, and water is always going to be our solvent unless it's stated otherwise. So dissolved in water, it's an AQ for aqueous. Okay, so that's just writing what the substances are. And once we know what the substances are, we never change them. And then we're going to, this is the by inspection part. It's a mathematical statement, and so we have to have mass balance, right? The law of conservation of matter. So we'll balance atoms on the left and the right by inspection, just by looking at it and figuring it out, but by multiplying by coefficients. So that we end up with the same number on each side. Okay, so you're just going to look at it and you put whole number coefficients on your substances on the left and the right until all of the atoms are balanced. So all irons are the same, or all oxygens are the same. But here's the really key thing, and the only way that I normally see people make mistakes is when they start doing things besides using coefficients. So that when we balance a reaction, that's the only thing we can change. Coefficients. So coefficients, those are the numbers out in front. It's how many of that molecule we have. And so when you do that, you have to do this, that's supposed to be a W, without changing the formulas for the compounds. So that means is you cannot change the subscripts. You can't change it into something else. So the formula of the compounds, that's the identity of that. So you can only change the numbers out in front, the coefficients, how many of those atoms or molecules you have. All right, and then that's pretty consistent. But then different books will give you different advice on how to go about this. And when we get to some harder ones to balance, the oxidation reduction ones in chapter 4, which will come after the second test, so we won't do those now. There's a systematic process for those kinds of reactions. But for these first ones, we just balance them by inspection. Just means looking at it and figuring out what numbers work. And this is where some books will tell you to start with one thing, some will start with another, and it kind of depends on what you're balancing. And I'm not going to give you any like real tricky ones, right? That's not my goal. The goal is that you understand how the reactions have to be in balance and how to balance some basic ones. And so this is just a list of things that I think sometimes help. So hints. First hint would be, let's start with the most complicated molecule. And that sometimes will work better. Okay, I'm trying to write as neatly as I can, but there's a little bump under here. So you don't want to start with the simplest one. You want to start with one with more elements in it, because then you can change the simpler ones to match up with it. So sometimes that works. I'm not saying it works all the time, but sometimes that works. And or you can start with atoms that only appear in one substance. And actually, most of the things we balance, it's going to be the case that they all only appear in one substance. That only appear in one substance on each side, because that's just easier to do. If you've got atoms, a certain element that shows up in both of your products, then when you change one, it just kind of throws off everything. So those can get a little more complicated, but they'll usually work out. And then the last thing that I think sometimes help, so this is an and or statement, do hydrogen and oxygen last. And that when we do the redox reactions later, that's always the case. We do those in a certain order. But so those are the hints with doing it. Let's see if the last thing, the cool thing about balancing reactions is that you always know whether you have the right answer or not. And so then it's really important, once you're done, check to see if they're balanced. So check to see if all atoms are balanced. So you just count them up on the left and the right. And then once you know that they're balanced, check to make sure they're at the lowest whole number ratios. So reduce to the lowest whole number coefficients. So remember, coefficient just means the number that's out in front that tells you how many of that you have. Usually we don't have to do this step, but sometimes if things have gotten complicated and we've multiplied by things more than we needed to, we'll have to reduce them. But a lot of times we won't have to do this. But you have to check it at the end. Now, it still would be balanced even if they're not the lowest whole number coefficients. But in Gen Chem, they tell us they have to be the lowest whole number coefficients. And of course, on WebAssign, it's got to match what's in the key. So let's do an example. Let's do an example and see if that helps. So what's my example I want to do? All right, so this is going to be a long example because we're going to write it in words first. So bear with me because I can do this much better on the board, but we don't have that option. So we've got a sentence written out that tells us what happens in the reaction. And if I was only doing the pencast, I could hit pause and just write all this in. So I think I'm going to do that. But the YouTube keeps rolling, right? I only have one hand, so to do this with. All right, so I'm back. Long pause on the YouTube. So the example we're going to do is solid iron 3 sulfide. So we've got the naming coming back into play here. Reacts with gaseous hydrogen chloride, which is hydrochloric acid, which we had to memorize on the last set of material, to form solid iron 3 chloride and hydrogen sulfide gas. So sometimes we'll have to write the whole reaction based on what's written in words. So we got to first identify the substances. So I'm going to do that fairly quickly without going through all the things we did with naming, but I'll just say it verbally, okay? So sulfide is in group 6A, so it's always -2. The 3 on the iron says it's +3. So that means we're going to need 3 sulfides to get to a -6 and 2 irons to get to a +6. So it's Fe2S3. And then it says solid, so we have to put a S there. Now it's not subscripted, it's just in parentheses S right on the same level. And then hydrochloric acid, luckily we memorized that one, HCl, and then it says it's gas. And then to form or to produce iron 3 chloride, well, chloride's in group 7, so it's always -1. This is +3, so there's got to be 3 chlorides on there, right? So FeCl3, and that's also a solid. And then hydrogen sulfide gas. So how do we get hydrogen sulfide gas? So technically, if we were doing our naming, sulfide is -2 because it's in group 6. Hydrogen's a +1 ion. So we need 2 of those. So this is covalent. So it really should be dihydrogen sulfide, right? By our strict way that we did the naming. But nobody calls it that. It's called hydrogen sulfide. And so it's just H2S. It doesn't smell very good. And that's a gas. It's poisonous, in fact. All right. So now, in balancing this, I would go back and forth with inspection and just try and figure out what coefficients, what numbers out in front of each of these will work to make it balance. Now, again, like I said previously, the most important thing is that we never change those, right? Don't change We can't change the subscripts on any of these. If we do, we're changing the identity of the substance. So we can't do that. So when I balance this, what am I going to start with? Okay, what's my strategy? Well, we could just look at it, right? We can see, well, I've got 3 sulfurs here, a sulfur here. So we know there's going to be a 3 out in front of there because sulfur only appears in this and this. So whatever this is, this has to be 3 compared to this coefficient, right? This has to be 3 times as much as that. And in fact, those of you who are mathematically, you know, you could set this up and do this. You wouldn't need to on this one, but this is going to have to be 3 times that. We could start there. That would certainly work. Especially we've got this hydrogen here, and we know, you know, if we started with that, then it's not going to work out. We could also start with the iron, right? We could start with the iron, and whichever one, whether we start with the sulfur or the iron, I think it's going to work out because, you know, this isn't one that's going to end up being super tricky. So I don't know. Let's start with the iron, shall we? So there's 2 irons on the left. So this coefficient has to be a 2, right? And then the irons are in balance. Well, when we change that, now there are 6 chlorides and only 1 on the left. So that means I need a 6 out in front here so that the chlorides are balanced. Now, why did I go right to the next thing that was in that compound? Well, it just made sense to do that, right? The irons are balanced. Let's do the chlorides. Then that changes the hydrogens. And now we have 6 hydrogens. So let's put that 3 out in front. And look at how that worked out. That 3 balanced out the sulfurs. So had we started with sulfur, the same thing would have happened. We would put a 3 here. We'd add 6 hydrogens. We put a 6 there. See how that works? And then there's 6 of those, so we need a 2 here, which matched with the iron. So no matter where we started, that one would have worked out. All right, now we need to check it. Always check, especially when you're starting on these. So I would even set up a table. You could say left and right, or reactant product like this, and just do all the elements. So I'll just start from left to right. We've got irons in the reactant side. We've got 2. Product side, we've got 2. We knew that. That's good. Sulfur, we've got 3. And then sulfur, we've got 3. And then let's see what's next. Hydrogen atoms, 6 hydrogen atoms. 3 times 2 means 6. So there's 3 of these molecules. Each molecule has 2 hydrogens. That's a total of 6. And then the last element is chlorine. There's 6 of them, and 2 times 3 is 6. So that's balanced, and it's good. Let's see. Let's do one more easy one. Now you hit pause. I'm going to actually write this one out, not in words. I'm just going to give the reaction just to save time. So hit pause on the video and balance this one. So I've got copper solid plus silver nitrate, and that's going to be aqueous, going to produce solid silver plus copper nitrate, and the copper is going to be +2, and we'll need 2 of those nitrates, and that's aqueous. All right, so, oh, sorry, I was off the screen for the YouTube. Here it is. Solid copper plus silver nitrate goes to silver plus copper nitrate. Balancing this, where are we going to start? Okay, well, we've got 1 copper, 1 copper, so that's not getting us anywhere. Silver's not going to matter because, Well, in fact, both of these, the silver and the copper, are by themselves. So we can put any coefficient we want on front of those to balance it. So that's going to be easy peasy. Well, in this case, we've got a nitrate on the silver, two nitrates on the copper. We can actually treat this polyatomic ion like a group because it doesn't change from left to right. So, I mean, there's two nitrogens in there and six oxygens, but it's probably easier just to say, I've got two nitrates here, so I know this needs a coefficient of 2 out in front, right? And that'll get it in balance. And remember, don't change any subscripts. Don't change the identity of the substances. So we put a 2 out in front, and then that means we have two silvers, and now it's balanced. And you can go through and check it, right? One copper, two silvers, two nitrogens, 2 times 3, that's 6 oxygens, 2 times 3, that's 6 oxygens. All right, so I'm going to record another video with some other examples. Thank you.